Alrighty, good morning, everyone. Thank you for adjusting to our subplans here. Obviously, this is not ideal, but I want to make sure that you at least are able to see a demonstration or a little explanation for our problems here. If you haven't done so or received these already, these should be located for our Chapter 8 packets here on polynomials. They should be located in the front of the classroom near the little folder box under the TV. So please go ahead, grab that, make sure you got yourself set up. You should have already received these already. But we're going to get started here. I would encourage you to actually try this lesson on your own. It's all about identifying the patterns here in 8.1. There is also an answer key on Schoology that you could follow along with. Otherwise, throughout this video, I would recommend I will always suggest pausing it at different times, trying a problem. Maybe you need to pause it to make sure that you have all the necessary material as well. We're getting started here in 8.1. What's the difference? So we're going to start off here by looking at some different block patterns. And what we're going to do is we're going to actually count up how many blocks are in each of these patterns. So in this first one here, there's obviously one block. There's 3 in the second, 5 in the third, and then 7 in our fourth pattern. Now, what we want to do is we want to find the difference here. So in B, it says find the difference between the number of blocks. So I'm going to show this or illustrate it by drawing some little lines. And from 1 to 3, that's a growth of +2, 3 to 5, another +2 difference, and +2. Now, I hope that this is familiar to you because this goes back all the way to 8th grade with our linear algebra. Now, they want us to make an equation for this function. Now, if it's growing by 2, that means that our slope value is going to be 2. So we're going to go y equals 2x. And it actually started off at 1. That would be considered our y-intercept. So our equation here is going to be y equals 2x plus 1. This is a linear pattern. Now, I wish that this chapter was as simple as linear. We're going to be kind of expanding these now, but our main focus is identifying the differences between the blocks here. Make a pause if you need to, get caught up, and then we're going to move on to number 2 here. So in number 2, we're going to go about it in the same kind of fashion. Count up how many blocks we see. There is 1, then we have 3, there is 6, and then there is 10 in our fourth figure. Now, that difference between the numbers here, that's our question here in problem B, is there is a +2 difference, a +3 difference, and then a +4. Now that number is not constant. That means that we're not working with a linear equation here anymore. So when it asks, is there a common difference, we're going to say no common difference. And I'm going to go kind of like a ... to build some suspense, and there's a no common difference yet. If we continue trying to take on this pattern here, I'm going to change the color here, we can actually take our common difference value and we can find the difference between those numbers as well. Well, the difference from 2 to 3 is going to be a +1, and the difference from 3 to 4 is going to be a +1. This is important because this is kind of the new look of our equations. This is starting to explain a deeper concept called polynomials. Now, is there a difference? There is no common difference but we get there eventually. Alright, so now in problem D, we need to write an equation for the pattern. Now, I'm going to be a little brief about this, but the equation that we form, or end up ultimately forming, is y equals 1/2 x squared plus 1/2 x. I'll explain more how we develop those equations here in a minute, but the important thing that I want to draw your attention to is this squared value. Now, if you don't remember, this squared value tells us that we are no longer working with a linear equation, but that squared tells us that this is a quadratic. Now, when we have these quadratics, these are formed by finding the difference of a pattern. And then we're going to essentially identify how many degrees these patterns are changing by. We're going to take care of that here in number 3. If you need to make a pause, please make a pause, give it a try. If you would like to, I would also say make a pause on the video and try to identify the pattern here in number 3 alone before I go over it. Assuming you made a pause, or maybe you didn't, I'm going to proceed with the video here though. In A, I count one pattern, or one block in that pattern. In the second, that's a 4x2, so that's going to give us an 8. This is a 3x3, or a 9x3, so that will give us 27. We have an 8x4. No, that's a 1, 2, 3, 4. It's going to give us a 64. And then there's 125 blocks in our last little figure here. Now, if we want to find the difference here, it says, is there a common difference right now currently? We can just say no. No need to explain. But if we found there is a +7 difference, there is a +19 difference between 8 and 27. Between 27 and 64 there is a 37 difference, and between 64 and 125 there is a 61 difference. Now, it's going to be really important that you also make sure that you're using the proper addition or subtraction sign for the difference of those. That'll make sense in a later example, but always get in that habit of putting a plus or a minus. Now, they want us to take another difference to see if we can find a consistency between 7 and 19. That is going to give us a +12 difference. Between 19 and 37, it's a +18 difference. Between 37 and 61 is going to be a +24 difference. So when they say, is there a common difference? No. Now we're going to take this and go about it one more time. Between 12 and 18, that's a difference of 6. Between 18 and 24, that's a difference of 6. Now, that difference that we're changing by is now constant. So because, if we went about it one more time, is there a common difference? Yes, we found a common difference of +6. it's going to be really important for us to understand that we need to find a common difference between the figures. And it might not seem like it at first, but a lot of these figure patterns will eventually lead, if we keep finding the difference of a difference, to a consistency. Now this is going to open up our talks about how we develop these equations, and this is going to open up a conversation of the degree. Now the degree is calculated by how many times we actually went about finding those differences. So if we found a consistency between the first common difference, this would be considered degree 1. If we found a consistency in our second attempt, that would be considered degree 2. And if we found a consistency, which we did in this example, that would be considered degree 3. So we know that for our degree value that this is the third degree. And we can use this idea to make an equation. And we're going to go y equals x. And because this is at the third degree, for our exponent value, we're going to write in the number 3. So we got our equation formed here, or general equation. So how is this type of equation different from the equations in our first two examples? This uses a higher, you could say, degree or power of x. Now, how do you think the differences in a sequence are related to the type of function of the sequence? I'm going to say the number of levels, or you could say common difference, to get a common difference matches the largest exponent in the equation. If you need to make a pause, please do. We're going to move on to our quick notes here. So, lesson 8.1, our quick notes in summary. What is a polynomial? So, a little definition that we want to put down is a polynomial is an expression that contains terms of constants and or variables with whole number non-negative exponents. If you need to pause, please make sure you get that definition down. In standard form, the powers of x are written in decreasing order. We will see some examples of this coming up. And then lastly, the degree is the largest power of x. We're going to see another example of that coming up here. hang on here, let me get through the bell. The leading coefficient in these equations is the constant multiplied by the highest power of x. Make a pause. Please make sure you get that written down on your notes. That is a summary of what is going on with these polynomials. Now, we have a couple examples of items that are polynomials and items that are not polynomials. So, kind of running out of some space here, but so why don't we go polynomials and then not polynomials. These are some quick identification methods. Well, if we have a -2, let's just say we have 1/2 x minus 4. These are all separate equations. We have x minus 1, x plus 2 in factor form, and then a slightly larger example, -4x to the power 3 plus 2x squared plus 3x minus 4. Now these are all examples of different types of polynomials that we see, and what we're going to do is we're going to identify the degree. Now this is just a constant term. There is no x value, there is no exponent. That doesn't mean it's not a polynomial. This is going to be a degree of 0. In 1/2 x minus 4, I see a single x value. That means there's like an invisible 1 that would be an exponent to it. So this is going to be a degree of 1. In this example, if we actually used our generic rectangle and we factored or FOILed this out, an x times an x is going to give us an x squared. Because that power is 2, this is going to give us a degree of 2. And then in our last polynomial, I see that our highest power is a 3. We do have a 2, we have a 1, and a 0 in there, but we have to take the highest power. So this is going to be a degree of 3. Is the bell as obnoxious through video as it is in real life? We're going to see some examples of not polynomials, of what we can't see. So we have an x to the power of -2. We're going to go a square root of x, 2 to the power of x, and then an x minus 5 over x plus 1. Now, these are not polynomials because, one, we have a negative exponent value. That's not allowed. We cannot have a square root. This is actually an exponential. It's an unknown power of x, so that's going to just give us a straight up curved graph, not even a parabola, not a polynomial. And then if we are dividing here, those x's actually cancel out, and we're going to avoid that as well. It's not a polynomial. So we have an example here to the left. Which of the following is not a polynomial? Well, this is going to be a degree of 0. X and an x is going to make a squared. That's going to be a degree of 2. Our highest number here is 4. All other numbers, that's a 1, that's a 0, that's allowed. So this is going to be a degree of 4. But in D, I see that we have a negative number. So our answer is going to be D. We want to find the degree of the polynomial in our table here as well. We would use our methods for finding the difference here if we want to find the degree. was the last bell, so we made it through it. Alright, between negative 10 and 8, and this is why I say you need to pay attention to your negative and positive numbers. The difference between negative 10 and 18 is going to be plus 28. I'm going to zoom in a little bit. From 18 to 51, that's a difference of 33. Plus 40. Plus 49. And plus 60. Still no constant, so we're going to keep trying to find the difference here. It's going to be a plus 5 difference, plus 7, plus 9, and plus 11. It's starting to look a little promising. It's going to be a plus 2 difference. We got our constant value. This would be considered degree 0, degree 1, degree 2, and with that set, it's going to be degree 3. So we know that our leading exponent is going to be to the power of 3. Make a pause if you need to. I highly encourage on our Check Our Understanding that you try these problems here alone, maybe with a partner. I will go through it here in this video. Quick methods. In A here, we're looking at our polynomial. It meets all the criteria. I see that our highest power is 6. I'm going to say yes, this is a polynomial, and the degree is 6. It is possible. What we see here is we have a division amongst them. If we actually simplified this out, if we used our exponent rules, this would be even 7x to the power of negative 1. We know that that is not going to lead us to a favorable outcome because we have a negative exponent, so we're going to say this is not a polynomial. So we're just going to say no. 2 to the power of x, that's an unknown value of x, it's an exponential. So I'm going to say exponential, no. The number 32, just because it's alone doesn't mean that we don't appreciate it. There's no x with it. No x value, but we still like those constant numbers. This is just a degree of 0, so we're going to say yes. Degree is equal to 0. There's nothing else that leads us to believe that it is not a adequate polynomial. Once again, if you haven't done so yet, try these problems on your own. Try to find the differences. We're just trying to find the degree here. But in our table A, difference between 0 and negative 2, you got to be really careful. Between 0 and negative 2, that's a difference of negative 2. Notice the minus sign. The difference between negative 2 and 2 is going to give us a positive 4. Between 2 and 18, it's a difference of 16. Between 18 and 52, that's a difference of 34. So we don't have a constant yet, but we'll keep going to see if we can make it. It's going to be a difference. Between negative 2 and 4, that's a difference of plus 6. We get a difference of plus 12. Between 16 and 34, that's a difference of 18. I'll try taking it one more time. 6 and 12, it's a difference of 6. 12 and 18, that's a difference of 6. So if we want to figure out the degree, this would be 0, 1, 2, and the third degree. So this is degree equals 3. And B, between negative 14 and 9, it's a difference of plus 5. Between negative 9 and negative 4, it's a difference of plus 5. -4 and 1, that's a difference of +5. Oh, that's really nice. Between 1 and 6, it's a difference of +5. So this would be degree of 0, degree of 1. So then this would have to be degree equals 1. Actually, when there's only a first degree polynomial, this is not a quadratic, this is actually linear. With the remainder of the time, I would suggest trying out the homework. I do have the pink homework solutions to 9.1 on Schoology as well. Take your time, try it with a partner that you're sitting with, and I will see you all on Thursday when I get back. Thank you so much for being flexible and watching this video.